Okay, welcome all. Again, welcome to yet another mastery learning portal. So let's jump into our problem statements. So today we're gonna see another easy problem, which is converting Roman to integers. So one quick thing before jumping into this, I'm already familiar with this program. Oh, my internet is a bit slow today. So I already familiar with this program, and I already faced this program in Amazon coding interview round, which is a first round in Amazon. So for the software development engineer, I applied for software development engineer role 1. I think it's the first role after my master's. So at that time, the same question was asked. So the quick thing which I would like to say, during that time, Amazon used to give like first online coding round. So primarily which focus on like it's either hacker rank link or basic coder pad link or something. But I remember that I think it's a hacker rank link. So it's the complete exam, it's around like a 1.5 hour, the time frame, and total questions are 15 questions. And these 15 questions, 13 questions are multiple choice questions, and last two questions are last two questions. One is a coding question, and the second one, which is time complexity and space complexity of space complexity of the coding problem. So yeah, you have to write a explanation for time complexity and space complexity for this coding problem. So at that time, I got this question during that time. So it's a very straightforward question. Like you have to convert Roman numbers into normal integer format. So for example, you can see that if input is 3 i's, like the string format 3 i's, that's output is a 3. So if you see the complete question here, so these are the basic symbols which represents Roman representation. I is a 1, V is for 5, X is for 10, L is for 50, C is for 100, D is for 500, and M is for 1000, like that. And for example, 2, you had written 2 i's. If you see 12, it's gonna be like a 10 plus 2, so X2. So like that format. But Roman numbers comes into a bit different way. I'm sorry. So when we are writing any code, any Roman representation, if a smaller value present in front of a bigger value, here you can see that I and X. So I value is a 1 and X value is a 10. So anytime when we see a smaller value in front of a larger value, here example is like X. So you know that, right? 1 is less than 10. So in a Roman representation, this is nothing but 9. So let me maximize this. This value is nothing but 9. So why? If left side argument is lesser than right side argument, you will do the subtraction. So this is the same way. If you do like IV, so you know that, right? Like left side 1 is a 1 and IV is a 5. So 1 is less than 5. So the result is 4. This is the same way we will use. So if you think about IV, it's the same. 1 1 5 if you think like individual components, like individual character representation, 1 1 5. So 1 is equals to 1 when we are coming from left to right direction. So when you are comparing next one, 1 is lesser than 5, so this value will be 3, because 5 minus 1 4, again 1 4, like this one if we write like this. So if you come from right to left direction, so first we compare with the 1 with the 5, so you know that it is a 1 is less than 5, it's the same operation here. So you will do that 1 comma 4, again 1 is a less than 4, so you have to represent it's a one more time subtraction, which is a 3. So another format of representation, that is 3 representation is 3i2. Okay, 3i, both you can see that. So that is what Roman number representation. This applicable to any configurations here, which means like if you write here, you can see that L is a 50 and C is a 100, right? If you write LC, assume like a Leetcode. Yeah, if you write LC, so L is a 50 and C is a 100. So 50 is a less than 100. So Roman representation, our normal integer representation, which is nothing but 50. It's the same way. If you write CD, you can see that C is a smaller than D, right? C is a 100, D value is a 500. So it's gonna be 100 less than 500. So it's gonna be 400. Okay, that's what representation. Okay. So this is what a representation. You can see that here in example LV 3 times, 3 i's. L is a 50 here, whereas a V is a 5 and 3 ones, which is a 3. The sum is like 50 plus 5 plus 3. So in this format, if you read from left to right, all are keep on increasing. So you can see that L is a 50, V is a 5. All are keep on decreasing. So you don't need to do any subtraction here. So 50 plus 5 plus 3, it's going to be 58. So in this representation, you can see MC, MX, C, I, V. So if you go like this, M is 1000, that's a good. But if you see C is 100, okay, and then M is 1000. So you're increasing order, right? Like a C is 100, M is 1000. So you have to subtract that. So CM represent 1000 minus 100, which is a 900. Similarly, XC, if you see that, it's gonna be X is a 10, C is a 100. So 100 minus 10, which is a 90. So I and V, same way, it is a 4, because 1, 5, it's the same concept here, 1, 5, and then it's a 4. So by looking at that, what kind of questions you can ask to your interviewer? This question, well, if this question popped in your interview, what kind of questions you can ask before jumping into that? Okay, so you can ask that, is it always guarantee that given string is a Roman number, right? That is a constraint. You can see that it is a guaranteed that S is a valid Roman number in the range of 1 to 3999 including. So this is a one good question you can ask, like what we need to do if it is not, let us assume the given inputs are these characters, but if somebody gives like T is not available here, so what do you want me to do? So you have to return an exception, or you wanted to return null value, or you wanted to compute any value like that. And as parallel as that, you can ask like, is there any chance that the return output can be exceed the integer value, right? But again, that constraint also covered here. The return value return value guaranteed that it is between 1 to 3900. So these are the questions you can ask that. So yeah. So what is the core logic here? Like when you write this code, what is the core logic? The core logic is a pretty simple. You have to, when we are seeing this in this example, you can see if 1 and 5, when we are comparing that, you can see pretty much you're traveling from right to left. When we are writing any of the integer numbers or any English text or anything like that, we always go with left to right direction. But if you observe Roman numbers, so most of the cases it is traveling from right to left direction, right? So that is the reason. Let us see this one, an example which I would like to explain here. So let me take here, this is the input. Now let me put it these values too. Okay, rather than doing this way, let me remove this. C is 100 and X is 10. For clarity purpose, I'm keeping everything here. And yeah, 1, I'm not going to represent 1, but this is a 5, right? This is the format. So if you read from right to left direction, first character is a 5, right? V, first character is a V, so put result as a 5. Clear cut picture, no need to worry anything. Now read the second character, right? You can see that second character is a lesser value than the previous value, which is a 5. So you have to subtract. If it is a lesser, means like, so let us write an abstract code. What we will write is, let's put it this as a current, maybe like a current result. Okay, so take the current result. When we are traveling from backward direction, I'm traveling this way. I'm not traveling from left to right, I'm traveling from right to left. So current result, put whatever the result you read. So from the character V, it is a 5. Take that 5. Okay, now you have to get the previous value to, okay, check that if it is a previous value is a lesser, means the previous result, okay, if previous result, where here in this condition is a 1, we need to check if previous result is lesser than current result. If it is a previous result is lesser than current result, we need to do a subtraction operation. Okay, so what we need to do, the current result has to be subtract with previous result. That's it. If you able to do that, that is our core content. Okay, so what I'm going to do, so if we perform this operation for all the characters one by one from right to left, that's it. You can get that complete result, right? So next, in the iteration, next iteration, you will get, okay, so what we'll do, the current result, we got it. So let us keep it that as a complete result. Result equals to current result. Let us assume that. Okay, or else other than we can do that directly here itself. Result equals to current result minus previous result. That's it, right? So we don't need to assign anything. If it is not else condition, if it is not lesser value, what we can do, we can directly assign current value result equals to current value. That's it. So when we are iterating the same logic second time, so right now at the end of this code, the current result, we can initialize that current result with the 0 initial time. At the end of this loop, you'll get a current result as 5 minus 1, which is a 4. Okay, now when we are iterating the next one, the character is a C is a 100. You will keep current result as 100. You will go to one block backward direction. You can see that X is at 10. It's the same concept again. Previous result is less than current value. So current value, we will do that subtraction. Okay, sorry, here result plus. You need to do that previous sum, right? Like whatever you have 4, you don't want to lose that. You have to add that. So now current result, which is 100, minus previous result 10, which will be 90. 90 plus 4, this will be 94, right? So like this, you have to go backward direction and until you get that complete concept, until you get that complete value, you have to iterate through one by one. Okay, so this is the core logic. Let's write the code. If we find any bugs, let's do that, and we can solve that bugs or any corner cases if I miss. Let's do that. So what I'm going to do, in the initial time, I'm going to put all these details into a map, which is going to be a hash map. So a map is a collection framework. It's a Java inbuilt library. So I'm gonna put that here, map equals to new hash map I will create. This is just for to keep that characters with the integer list. So from Java 8 onwards, you don't need to represent character and integer here. You can just define like this, generic format. So what I'm gonna do here is I will convert character, the input string s into character array. So I'm gonna do that char maybe like input equals to s dot to char array. Okay, so now we're doing that. I'm gonna put I will write this one map dot put statement where we will put this all these characters. Let me copy this, copy. So what I'm gonna do, I'm gonna repeat the same statement again. Oops. Okay, now the same way I will define the same information here too. Like I will create one value result which is 0 for now. I will create. Now I will do this way. So as I mentioned here previously, when we are iterating to this input characters, Roman numbers, you have to go backward direction. You don't need to go left to right. You have to go to right to left. How we can do? It's a very simple. Index equals to our, let's do it, this is a input. Okay, let's iterate to that. Input dot length -1, and then I index, usually I will prefer to give a name as in I, so less than or equals to 0, and I will iterate to this. So now I'm gonna get current result, which is nothing but this one. Okay, current result equals to, I need to get the integer value of a given character. So what I'm gonna do, I will use that map dot, I will use map dot get the corresponding input array of index, so which gives us the corresponding integer value. Okay, now what I'm gonna do, now I will take previous value to int previous result equals to, which is nothing but the previous Roman value. Maybe we can write like a previous Roman number or Roman value. Okay, so where I will do here is I will do that map dot get index -1. Okay, now what I will do, I will write one code where I will check that if my previous Roman value, which is nothing but here I use the term as a previous result, but here it's just nothing but a previous Roman value, which is lesser than which is lesser than current value, then I will do this operation. So which operation we have to do, result plus equals to current result minus previous result, previous Roman value. Okay, if it is else condition, okay, if it is else condition, or we can directly write okay, yeah, if it is else condition, we'll do that else equal to plus equals to current value. This is a straightforward answer. Okay, that's it. You don't need to do anything apart from that. We just need to return this result, right? So we are keep on going backward direction. Each value we are comparing with the previous value. If it is a smaller value, we are doing the subtraction, and we are keeping doing. But here comes to the one more question. So when you reach here, right, when you are coming to the 0th position, you need to make sure that you are not going index -1, right? So if you go index -1, what is going to happen? It will go give index out of bound exception. So what I'm gonna do, I will write rather than doing this way, because if you run this one, this will give like index out of bound error, because this will give index out of bound error for when value is a 0. Okay, 1 second. Oh, sorry, this is a index minus. Yeah, right. If we run this code, run the code. See, index out of bound exception when index -1, out of bound for length 3. When we are giving that index value 0, then there is a chances that I mean, when index reaches to 0, there is a chances it can go out of bound exception. I mean, 0 minus 1 will be -1. That's why it is giving index out of bound. So what I'm gonna do here, in if condition itself, I will write like this: if index is a greater than 0, okay, and what I'm gonna do now, previous Roman value, instead of doing that, I'm gonna do this way. Okay, so I don't need to keep it a separate variable, so I'm directly fetching that if index is greater than 0, so that if it is at least one value is there, then only go and look the previous value. Example here, for x, go and look that m value. For m, go and look the previous value c. For c, go and look the previous value m, like that. So if it is a 0 index, don't look at the 0 minus 1 position. If it is that value, I'm gonna do map.get index position, right? That's it. Now understand here, in this if loop, we are monitoring this value too, right? Like, I mean, let us assume when we are traveling in backward direction, for v, we looked into previous element, which is a 1, and 1 is less than 5, so we subtracted that 1 minus 5, right? So which means like you already covered this one. Do you need to add again one more time? You don't need, right? You don't need to cover one more time, right? Because if you, I mean, what is going to happen otherwise? You're going to get a 4 here, and then you will add a +1 again, because index position will be there. So what you need to do, you have to do index -1 one more time, right? So what you need to do here, we can put that index minus, because we are already checking that index -1, and if it is a lesser value, we are doing that operation here. That is the reason we are doing index minus. The reason is we are giving that we already covered this character, so that's why you need to go to the next character, like that. Okay, let's run now. Let's see if we are able to solve this problem. Okay, looks like some, oh sorry, I missed balances. Yeah. Oh, okay, no worries. Yeah. See, now 3 looks good. 3, because 3 doesn't go to this if condition at all. Most of the time it will go to else condition, because all are equals, right? There are no subtraction operation or in decreasing order. Let's do this one. Okay, 1v, let's run the code. You can see 5 minus 1, it should give 4. See, that's a good. Let's try other input values too. Let's do string value, this one. So we have to expect 50 plus 5 plus 3, 58. That's cool. Again, this doesn't go to the sorry, this also doesn't go to if condition, because all are like a I mean, there is, if you travel from right to left direction, there is no decreasing element before that. Let's copy this one as an input. Let's try this one. Run the code. Okay, sounds good. You can see that 1994, it's coming. So if you, I mean, if you don't understand, or if you wanted to debug a little bit more, you can do here is like you can put a system.out.println, and you can compare individually like current value and map.get value. You can display that too, so that you get like what conditions it is going inside and like that. So let me write that one for a debugging purpose, so that it is a very nice way to understand. Okay, I'm gonna put this value. Okay, I'm gonna put a comma as a value, separated, comma, delimiter, and current result. Observe here. So when we are observe here, when we are running this code, mcmxiv, yeah, see, when it is a 5 and the previous element is a 1, it moved inside this, I mean it went inside this if condition, and it does that subtraction 5 minus 1, which is a 4, and then next it went to like a cx time, whereas a x is a 10, c is a 100, x is a less than c, right? So then it does that subtraction 90, 100 minus 10, 90 at the time. And then after this x completion, then it goes to m and c. You can see that m and c condition wise, c is 100, m is 1000. That time also it does the subtraction 1000 minus 100, which is a 900. And when it comes to m, there is no elements before m. So here index greater than 0 condition breaks it. So it goes to else block, directly it adds into the cumulative sum to result. So that's why it is a 1999. 4. Okay, let's submit this code and see that if we all the test cases pass. See, that sounds good. So all test cases got passed and we got the result. Yep. That's it for today. Feel free to drop if you have any questions, or if you wanted to reach us, or go to our channel, go to our YouTube channel, go to you can go to our social media and you can reach us. If you wanted to directly reach us, you can submit the form too. Okay, that's it for today. Thank you. Have a great day. We'll see you.